All right, I'm back. I'm on page 259, and this is a big page for us. So this page is about limits and continuity, and we're going to talk about discontinuities, and we're finally going to, in writing, in print, I've said it at least a dozen times, we're finally going to get to the limit definition of continuity, right? Continuity at a point. So this is going to be a big deal. So what's really interesting, so any break in the graph is going to be called some kind of discontinuity. So you can have a jump, you could have a vertical asymptote, you can have a removal discontinuity. These are all types of things that can happen. So we're really obsessed with finding continuity. The way you find it usually is you actually search for discontinuities, which is why we need to know so much about those. Let's talk about the three-part definition of continuity, which you are definitely going to have memorized. I feel like I should make it an assignment for you to record yourself saying it like 5 times and I don't know, like upload it or something. I'm gonna consider that. So the function f of x is continuous at x equals c if, just reel them off, the limit exists, the function exists, the limit equals the value of the function. So the limit as x approaches c of f of x exists, f of c exists, and they give you the same value. So they have to both be finite, which it doesn't say there, but like f of c can't be infinity. Like that doesn't make sense. But a function is continuous at x equals c if the limit exists, the function exists, limit equals the value of the function. You've got to get all three of those into your brain. When you take the AP exam, there's probably going to be a question about that. This is the kind of thing like you have to memorize as soon as possible. Have I made that clear? I really, really hope so. So with that in mind, if the limit doesn't exist, or the function doesn't exist, or they both exist but they're not equal, then you have some kind of discontinuity. We need to know the exact names and definitions of each of those. So the first one is a removable discontinuity, which you probably have been referring to as a whole for most of your life. Let's use a highlighter. What color? This color. So here it is. A whole. So a whole is technically called a removable discontinuity because it's a type of discontinuity. Like what type of discontinuity? Removable discontinuity. So a whole or a removable discontinuity has the following definition. The limit as x approaches c of f of x equals L. F of c equals m, I should clarify here, or f of c does not exist. That should have been there. And L doesn't equal m. So the limit exists, the function could exist and not be equal to the limit. The limit exists, the function doesn't exist. You need the limit to exist, which means the limit from the left equals the limit from the right. And you need it to not be equal to the value of the function. That's what we need. So that's a removable discontinuity. Here's your graph right there. So in that case, well, I kind of obscured something. In that case, the limit exists, the function exists, but they're not equal. If that point wasn't down there, so if this wasn't here, it wouldn't make a difference. It would still be that the limit exists and is not equal to the value of the function, therefore removable discontinuity. Jump discontinuities. So a jump discontinuity is the limit from the left exists and is finite. The limit from the right exists and is finite, but they're not the same number. So we don't care about the value of the function. You never care about the value of the function. These literally look like you would have to jump to get from one to the other, right? So if we had our little stick figure, how do you show jumping? That's a jump. The only way to get from one to the other is you would have to jump. So jump discontinuity, both limits exist, they are finite, but they're not the same. And you know, people don't really have a problem with these. It's just you got to like get used to knowing the definitions. People have a problem with that because I feel like in math, maybe in geometry, there was a lot of stuff you had to like kind of memorize, but you sort of intuit your way through everything else. Like hit the unit circle, I tell you to memorize it, no one takes it seriously, and then suddenly it's all of a sudden like, oh, he really meant that? I really mean this. You need to know these definitions. Infinite discontinuity. So this is another one where you definitely know this, but you know it by another name. Okay, so you know these as vertical asymptotes. When you're referring to them as discontinuities, they are infinite discontinuities. The thing about them that makes them infinite is that the function itself will tend toward infinity or negative infinity, right? So we're approaching a finite number either from the right or from the left. And as we do that, the function goes up or goes down to infinity or negative infinity. So this is really weird. You only need one of these things to be true. You don't need both of them to be true. So you could have the limit, well, there's four options. The limit as x approaches c from the left could be positive or negative infinity. If that is true, you have a vertical asymptote, you have an infinite discontinuity, and you stop. You don't even really care what's on the other side. So if the limit from the left is infinity or negative infinity, vertical asymptote, infinite discontinuity. If the limit from the right is infinity or negative infinity, that's it. That's all you need. You don't need to look at the left. You just need one of these things to be true. Either this is happening, or this is happening, or this is happening, or this is happening. That's it. You don't need both. So any one of those. So the limit from the left is infinity or negative infinity. The limit from the right is infinity or negative infinity. You don't need both. So that's an infinite discontinuity. So these are the types of discontinuities. You know what those look like. They look like vertical asymptotes. So there are other behaviors that could have happened. Like you could have this or this. I feel like this is actually the only option. I feel like every option is covered here. No, there's one. There's the other one that's missing is up, down, I think that's all of them. I think that's all the options you can get. I don't know. But anyway, these are the types of discontinuities. Commit them to memory as soon as you can. Make flashcards, flip them over, know them both ways, looking at a graph, be able to say what kind of discontinuity and what the limits are that made that happen. Thinking of the definition, be able to just state the definition and create a graph. So you need to get this knowledge like workable from both directions. But anyway, I'm going to cut this one here, and I will be back in another video, and we're going to keep going. So hope you are finding these helpful.